All right, let's evaluate these log functions, okay? So when we evaluate log functions, one of the things we can do is, again, keep in mind what does it mean to be a log. A log is we're looking for an exponent, right? So we're saying, hey, what does 4 need to be raised to in order to equal 16? Okay, so we're saying, hey, we can write this as 4 raised to what power equals 16, right? And so when it's in this form, we could use the equivalence property for exponential expressions, because all we have to do is write this where it has the same base, right? So 4 to what power equals 16? Well, that's going to be 2, right? And so by using the equivalence property, we have two exponential expressions with the same base that are equal to each other. So this implies that x must equal 2. Okay? But that makes sense, intuitively speaking, just from our understanding of exponents, right? So 16, right? We know 4 to what power equals 16? Well, we know, well, that has to be 2, right? But that's also using the equivalence property, okay? In your head, without really thinking about it. So now, let's do the part B, so log base 2. So again, I would write this as, okay, what it's saying is, okay, 2 to what power equals 8? 2 to what power equals 8? And so now what I'm going to do is I'm going to rewrite this, because I want to write this with the same base. And so if I write this with the same base, 2, right? So 8 is the same as 2 to what power? 3. And so again, with the equivalence property, I know that if these two are equal, because they're exponentials with exponential expressions with the same base, then it must be true that the exponents must be equal. Okay? So we know, oh, so by the way, going back to this one, so we know, based on this, now that we solve this, then we know that log of 4 base, log base 4 of 16 is equal to 2. Log base 2 of 8 is equal to 3. Okay? That's all we're doing, is we're rewriting these in equivalent expressions. So now I'm going to rewrite this as an exponential form. So that means 1/2 raised to what power equals 8. Okay? So in this case here, we can rewrite what? 1/2, right? Or maybe you even know, right? So I know that if I raise this to the third power, that's going to give me 1/8, right? So in order to flip it, I have to have a negative exponent here. So it'd be -3. So maybe you could reason through it. So just kind of looking at the problem. But if you want to, again, rewrite this as, okay, 8 to what power, so 1/2 to what power equals 8. You could try to rewrite this and use the equivalence property, right? I know that, 2 to the third, right, is 8. But if I want to flip this, right, because this is the same as 2 over 1, and so again, I'm going to use another property of exponents. If I flip this, if I want to flip this, I have to change the sign of the exponent. So if I want to make this 1/2 from 2 to 1/2, I have to change this from a 3 to a -3. And now I can use the property of the equivalence property, and I know that since these two exponentials are equal with the same base, then I know their exponents must also be equal. And so the log base 1/2 of 8 is equal to -3. That's it.